Okay, good morning or afternoon to everybody. We're going to get started here. This session will be recorded. Hello, my name is Megan Moore, Sterling's VMware Partner Business Manager, and welcome to Sterling and VMware's Power Block session. We know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with us. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a VMware principal partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with an industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies, with more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is of the utmost importance here at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases you will find at the end of the demo. And for questions during the demo, please put them in your Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Billy Downing to demonstrate using NSX Advanced Load Balancer as an ingress for Tanzu Kubernetes Grid.
Awesome. Thank you, Megan, for the introduction. So my name is Billy Downing. I'm a cloud architect here at Sterling in our strategic services group. And today we're going to talk about how we can use Tanzu Kubernetes Grid, specifically the multi-cloud variant of it. And we'll talk about what that means and how we can integrate and use the NSX Advanced Load Balancer, which you might be more familiar with calling that Avi Networks. That's sort of the acquisition by VMware. We're going to take a look at how that integrates into these Kubernetes clusters, how we can use that to our advantage of having this application delivery controller or load balancer in front of our Kubernetes cluster that has a very robust features that are a little more in line with what you would expect out of an enterprise load balancer when compared to a lot of the open source projects that are out there today to do the same process, to accomplish the same goal. Then we'll do a demonstration and we'll actually take a look at how these things are put together. What does it look like in a realistic environment? I have a VCF on VxRail environment, and we're going to take a look at what I've done to deploy Kubernetes clusters using TKG multi-cloud on top of that environment and deployed Avi Networks or the NSX Advanced Load Balancer, and then went ahead and integrated the two for a fully functional Ingress point for my Kubernetes clusters. Excuse me. So first, I just want to frame the conversation around Tanzu, kind of what it is on a very high level. And I guess the best way to do that at a high level is just to describe the different licensing models that come with Tanzu. And I think that spreads kind of the idea of what solution we're trying to provide and what problems we're trying to solve here. So from left to right, we start off with Tanzu Basic, Advanced, and Enterprise. And starting out with Basic, essentially what that's going to do is enable us to deploy Kubernetes on premises directly on our vSphere platform. So what that's going to allow us to do is use vSphere as our common platform to deploy Tanzu Kubernetes clusters that are managed by vSphere. This is going to be using the project cluster API. It's an open source project that VMware contributes to heavily and integrated into this type of solution. So essentially what we're doing is we're transforming our vSphere cluster into a Kubernetes cluster to then manage subsequent Kubernetes clusters. So our units of deployment are going to be TKCs or Tanzu Kubernetes clusters for which we will then deploy our applications. That is where we're going to integrate Avi or NSX Advanced Load Balancer into our Kubernetes clusters to provide load balancing services as well as an Ingress controller to realize Kubernetes Ingress objects. The cool thing about Tanzu Basic is that it doesn't require, any sort of specialized tooling outside of your vSphere environment. You don't have to have vSAN, you don't have to have VCF, you don't even have to have NSX data center, which I believe is a common misconception, is that for vSphere with Tanzu, you have to have NSX installed and you have to have this very robust environment. But what we'll look at today is this environment that I've deployed. I'm not using NSX for anything. I'm not even using a supervisor cluster. I'm deploying it directly as you would if it were a normal cloud provider. And now that'll kind of make sense as we roll into what TKG multi-cloud looks like. The next step is going to be Tanzu Advanced or Tanzu Standard rather. And what that's going to do is provide us that multi-cloud support. So what that is we have this on-premises capability to deploy clusters into our environment. This next level of licensing is going to afford us the ability to span that across multiple clouds. So the tool we'll be using today in TKG multi-cloud is kind of the realization of that effort. We're going to use the same control plane to deploy TKG clusters in vSphere, just as we would deploying them into AWS or Azure. Then we can use something like Tanzu Mission Control, which is a SaaS-based product to orchestrate all of our clusters, to then pull all those clusters in and control them from a central point of orchestration, which is, a SaaS-based product that's built into AWS that we can then reach into all of our different cloud provided clusters, be that vSphere clusters or AWS clusters that are running, that TKG distribution of Kubernetes. And we're going to pull those onto a central location. So the first two levels of licensing are kind of focused on the infrastructure side of the house. So those are enabling your platform to support modern applications. The final and the most advanced and enterprise level of the licenses for Tanzu is going to be it's going to incorporate that entire developer stack. So that's going to include things that are such as Tanzu Application Catalog, which is going to be your secure source for application containers. It'll include the different lifecycle management or the different CI/CD pipeline and build tools that are required more for the development side of the house, as well as all the tools that come to enable your platform as a whole. So really what this is from a, from a right to or left to right kind of progression of adopting Tanzu. That first level is adopting Tanzu or adopting Kubernetes in your on-premises environment with the equipment that you have today. That next level is adopting Kubernetes in the environment you have today or in a cloud environment using a common distribution of Kubernetes in Tanzu. And that could be on-premises as well as managed out in a public cloud. And then the final stack of this, the final level of this is really to enable, now that your platform is enabled and you can build these applications, it's now providing you the tools and the pipelines used to then develop those applications for a cloud native type of infrastructure. So if you're looking at from a perspective of what would be best suited for you, it really depends on where you are with deployment of your applications, how you develop your applications, and how you are managing those applications. And that kind of determines what sort of licensing you need and what sort of features you'll be required to have to meet your needs. So what we're going to be using today is referred to as TKG multi-cloud. So I won't be deploying, I won't be showing exactly what, vSphere with Tanzu looks like as far as incorporating VCF and all of that, that full package of solutions. This is going to be the bare minimum you can use to get started with Tanzu and get started with Kubernetes in your environment. So this requires the least amount of effort from a deployment perspective. This is going to be deploying everything right on top of a vSphere environment without actually integrating directly into vCenter and deploying supervisor clusters and things like that. So what we're going to end up be doing is kind of have it listed here is we're going to be using Cluster API as our common management point. We're going to use TKG, the Tanzu command line, to deploy a management cluster onto our vSphere environment. And then from that management cluster, it will then deploy subsequent workload clusters that we're actually going to deploy applications to. Then we're going to integrate that into Avi, as we'll see in a little bit, and use Avi as our ingress, as well as our traffic flow and analytics into our clusters. So what this really provides, that concept of using a TKG managed management cluster to then deploy other Kubernetes clusters and lifecycle them from that respect, it gives us the ability to have a common distribution of Kubernetes across all locations. So we can have an endpoint as our on-premises vSphere environment, or as say we have an environment built out in Azure that we want to deploy Kubernetes clusters to, as well as AWS. And then if we were to use, in a more advanced services from the Tanzu perspective, we can then start connecting all of those together using Tanzu Service Mesh, which is a product based on Istio. So really what this is all coming down to is we are trying to provide we're trying to solve the problem of application mobility. So the goal of this entire solution is to provide you the ability to have an application built once to be deployed many times to different locations. So this can benefit you in a situation of application migration. Perhaps you are evacuating a data center into a public cloud and you want to have the common platform to be able to deploy to. This can also be very useful in a situation such as disaster recovery, where you have a common standard definition for your application used in Kubernetes artifacts built out into YAML files. And because Kubernetes is the underlying platform that's going to support your application, it abstracts the environment itself. So it abstracts away the nuance of AWS or the nuance of vSphere. And what that allows you to do is in a failure scenario, just go ahead and redeploy your application to whatever platform supports TKG, in this instance, AWS, Azure, or vSphere. So again, to kind of summarize that, why is this important? What we're trying to do is provide that application mobility. You know, the goal of a lot of our businesses is not to manage infrastructure, but our goal is to manage the resiliency and the efficiency of our applications as they sit. So that's kind of what we're trying to accomplish here with TKG Multi-Cloud and building out an environment that we can deploy applications wherever they may be using a common platform in Kubernetes. Specifically, the distribution is going to be Tanzu in this instance. So how does Avi kind of fit into this, and how does, or the NSX Advanced Load Balancer, how does that fit into this, this model of deployment? So just a little bit of recap of what Avi is. Avi, they're kind of interchangeable as far as the names go, but the NSX Advanced Load Balancer is going to be just as that. It's going to be an advanced load balancer that's going to be built out similar to how NSX Data Center is built, where we're going to have a distributed data plane using what are called service engines. And we're going to have a centralized control plane in our Avi controller. The way that it interacts with our Kubernetes clusters is built into TKG Multi-Cloud. We're going to deploy the AKO, or the Avi Kubernetes operator. And this operator is going to act as the entity that translates Kubernetes ingress objects, or a service of type load balancer, into API calls to our Avi controller. So if we're looking at this diagram here, towards the bottom, we have several Kubernetes clusters. And then in that cluster, we're running an AKO, or an Avi Kubernetes operator. So whenever an administrator is trying to deploy their application and they're trying to provide external traffic into their environment, they need some way to present a public IP address, or at least a routable IP address, into their environment as a central point to direct traffic flows. Ingress is going to be the object we're going to create for that. And if you're familiar with Kubernetes Ingress, that's going to require an Ingress controller. So in this case, Avi is going to be not only our load balancing controller for all of our normal applications we have in the environment, be that other virtual machines or physical boxes or anything like that. It can now also instantiate service engines and virtual services to provide load balancing and other security, such as web application firewalling, or WAF, among other advanced features like global load balancing, global service load balancing, and analytics that we'll take a look at in the UI. But what that's going to do is bridge all of your environments together. So it's going to be, you have a single point of application delivery in Avi, and that's going to be able to distribute traffic across all of your applications, regardless of how they're actually deployed in the environment. So how this is going to integrate, like I mentioned before, we're going to look at this and what pods are running in our clusters. And we're going to notice, we're going to see that AKO is going to be a pod dedicated to its own namespace. And every time we invoke the Kubernetes object that is going to be realized by Avi, that AKO, or that operator, is going to go ahead and translate that YAML file into API calls up to the centralized controller. That centralized controller is going to maintain that state of objects and then distribute them out to the data plane, which is going to be those service engines to actually realize those load balancing, ingress controllers, things like that. So this is a quick diagram of how does this actually tie together, and kind of why is this important. So going back to that as a summary, why is this important? So having a central point of ingress into your environment is critical to exposing and controlling traffic into your applications. So I've used the term ingress quite a lot. Ingress as well as load balancers. So if we're talking from a Kubernetes perspective, we can simplify this and how objects are realized in Avi. In a ingress is going to be realized as a layer 7 load balancer. So that's going to be typically for our HTTP and HTTPS traffic. And we're going to be able to dictate traffic flows based on the URL that our consumers are actually typing in to get to the applications. This will make more sense when I show what the actual object definitions and how they are realized in Avi. But just as a general rule of thumb, when I'm talking about Ingress, I'm talking about a layer 7 load balancer being created on the Avi controller. When I talk about service of type load balancer within Kubernetes, that's going to be a layer 4 load balancer that's going to be deployed in the Avi controller, and then filtering traffic based on services in our Kubernetes clusters. So the reason, again, this is important is this allows us to go ahead and distribute our traffic across all of our applications, whether they're in Kubernetes, in this case in TKG, whether they're in virtual machines, or whether they're bare metal entities. You can use a single software-defined load balancing fabric to provide that service for all of your different applications, regardless of where they sit, whether that's on-prem, whether that's in the cloud, or whether they're in containers, virtual machines, or bare metal. So with that, I will jump over to our live environment. And the first thing I want to do is kind of level set what the environment looks like from the vSphere perspective. So I'm looking at what I'm looking at here is a little, might seem a little cluttered, but what I'm looking at here is a VCF on VxRail environment. This environment does have Tanzu enabled. So if you are noticing this namespaces column here, that is a separate way of deploying TKG, and it's directly integrated into vSphere. But the way I've gone about it doing it here is to make it a little bit more separate so that we have the exact same control plane or Kubernetes that we can deploy into AWS or into Azure. So if we look here, I have a few different virtual machines, and what these are several different Kubernetes clusters that I've deployed using TKG. If you look at this node here, I have a TKG management cluster. So this is the cluster that's actually deployed and has the cluster API objects to then manage my subsequent guest clusters. So this cluster here, this TKG management, is actually my management cluster. I have several work clusters, so TKG work control, TKG Avi 01 and TKG Avi 02. These are all independent clusters, 2 node clusters, one control node and one worker node, but they're all managed by my TKG control plane. And so what this means is that, like I was mentioning earlier, if I want to deploy one of these clusters into AWS, I can do this just like I did into vSphere. There is a Tanzu CLI that we'll take a look at in just a second. And I can use that CLI to deploy into any cloud that is supported. At this point, it's vSphere, Azure, and AWS, with GCP coming soon. So what that means is each one of these clusters, if I deployed it on vSphere or if I deployed it into AWS, it will have the exact same components, the exact same networking, all the different things that you would use to manage and automate in your environment. So if I were to have a failover event, for example, every one of these clusters does come with Valero, which is an open source project that, again, VMware heavily contributes to. That is for backup of Kubernetes objects. So I can use Valero in these clusters to back up all of my Kubernetes objects into AWS S3. So if I have some sort of a failure, I can restore those into a TKG built cluster in AWS without having to worry about a lot of the nuance of the different environment underneath. Okay, so looking at that, those are the TKG clusters that I have. And if I scroll down here, I have an Avi controller. So this is my Avi control node that we'll be logging into. And this is what I would consider as a source of truth for my load balancing fabric. So this is an Avi, this is the actual control plane and the management plane for my application delivery controller. And what this is doing is when I invoke certain objects such as Ingress or service of type load balancer from Kubernetes, that AKO or that operator that's running in all those clusters that I just showed is going to translate that object into API calls to this control node, which is then going to instantiate those objects onto our service engines, which you can see here. So these service engines are actually the data plane for the traffic that I'll be demonstrating today. So all the traffic, as far as from the perspective of customer or consumer into your Kubernetes cluster, will traverse these virtual appliances here, these service engines. And the control node is going to be the source of truth, which configures those. So you can have dozens or hundreds of service engines supporting, dozens or hundreds of clusters and applications. And you never have to log into any of them individually. They'll all be honing back to your single source of truth in your Avi control plane. So if I look at this from a Avi perspective, in fact, before I do that, I kind of want to show that same outline of my clusters and what that is from the Tanzu CLI. So I use this Tanzu CLI, and here we have version 1.3. which is the latest release, I use this command line to instantiate and build out my Bootstrap cluster, which is also referred to as that management cluster. So if I were to go here and I would attempt to list my clusters out, this is interacting with that management cluster, could then name all of my workload clusters that are being controlled. So you can see here that I have those 3 clusters. If I were to go back to the vSphere CL or the vSphere UI, which there were 6 virtual machines made up of 3 clusters, not including my management cluster. Obviously, these are just workload clusters. I can see I can lifecycle manage these. I can deploy them at different versions if need be. But I can also use Tanzu to go ahead and get the different configurations for these different workload clusters. So what this is really providing, like I said earlier, is a way to use a CLI tool, or it has a UI as well. You can go ahead and deploy clusters across different disparate environments. And so, if I were to log into one of these clusters, let's log into this TKG Avi cluster here. So I'm already in that cluster right now. So if I look at this TKG cluster, I can see that there's a lot of, the normal what you would expect in a default Kubernetes cluster, but there's also a few other namespaces that are added by VMware. And these TKG system and TKG system public are going to be those different clusters that are deployed in order to have give you that out of the box experience so you can start using this cluster to build applications. So what we're focusing on here is this namespace here. That's that Avi system namespace. Here we can see that AKO. So this is that Avi Kubernetes operator that's running. And what this is doing is the node that is acting as an operator or a control loop for creating objects that are relevant to Avi. So whenever I create an object in Avi, it's going to run it by this AKO or this operator, and this operator will translate it and then interconnect with the control node that we just looked at to create these objects. So I just wanted to show this from the CLI perspective, just maybe so if it makes a little more sense as we're going through this process. And the text that I have up here is the application that we've deployed, and I'll jump back into that after I look at what it looks like from the Avi perspective. Okay, so we looked at our Kubernetes clusters. We have some applications running. We have some services running, and in fact, I will just show that to make that full picture come through. So if I look at this from a Kubernetes perspective, and I check to see what Ingress I have, or what Ingress objects I have, I can see that I do have an Ingress object, and I'm calling, it's going to be referred to as this URL, and it's actually reachable on this IP address. So all of this was actually instantiated by Avi itself. So when I created this object was realized in Avi, and Avi actually also provided this, this IP address. And Avi is authoritative on this URL, which I'll be using to access my application. So we'll look at Avi and how that actually is instantiated in just a second. But the object from a Kubernetes perspective, if we look down here and I create this Ingress, what I'm doing is creating a layer 7 firewall, and I'm creating rules within that firewall to determine the path or the URL that a consumer is interacting with our cluster with determines the service that is going to send that traffic to. So essentially what I'm doing is creating a layer 7 load balancer that is able to identify HTTP headers or HTTP URL destinations and then route traffic based on that. So what I've deployed alongside this is a few different applications. So I've deployed a homegrown application called GoFigure, an Apache or a Tomcat server, as well as my default one is going to be sent to a load balancer service that is for Nginx. So I essentially have 3 different applications that are all managed by a single load balancer VIP, and they are separated based on the actual URI that is being used to interact with the cluster itself. So how could this benefit you from a Kubernetes perspective? If we're not talking about Avi, we're talking about just the Ingress in general. If you think about developing applications in a microservices-based architecture, oftentimes you have sprawling APIs or you have sprawling microservices that need to interact with one another. And so sometimes it becomes very cumbersome to create individual load balancers for every single one of those services that needs to be exposed to your consumers. So rather than creating a dedicated load balancer VIP on a per service basis, an Ingress allows you to go ahead and filter that traffic using a single load balancer VIP, and based on the URL, forward that traffic to the service that's actually necessary for it. From an Avi perspective, so we have all these objects here. From an Avi perspective, we can see how these objects are actually realized. So let's look at this, this layer 7 load balancer here. And we can see, just like I had in my YAML file, I had 3 different services to 3 different URIs, my Apache, Go Figure, and default. And we can see how those are actually connecting into my servers that are hosting the application. So I just have very basic an Nginx server running and a Tomcat server running and then a custom app running. And we're going to see how this load balancer using a single entry point VIP is able to then distribute traffic across those different services based on our URL that we're using. So what benefit does Avi bring to this as well? So if we're looking at this from if this is being instantiated, if I look at my virtual service that is actually controlling this traffic, the first thing you get with Avi that is unique amongst a lot of the open source products that are also act as Ingress controllers is the analytics that's provided. So we can see here that I have pretty in-depth analysis, not just from the perspective of applications within my cluster, but also from the perspective of clients accessing my cluster. And I can understand exactly, based on the common trends of application access, what the average times are from the client to my load balancer, and then how my application is actually reacting from within my cluster. And I can, have a gauge of what's the operation or the average response time or total time from in transit from the client into my cluster, and how long my application takes to actually respond to that. So what this provides you the ability is to determine the fault or determine cause of any sort of performance issues pretty quickly. I don't know if there's any network engineers out here, but oftentimes the network is always the issue. And analytics like this provide you a nice little tool to understand if it's whether it's the application responding to the actual request, or if there's an issue with the client actually reaching the load balancer in the first place. So another aspect of Avi that is pretty critical to from the visibility perspective and the benefit that Avi can provide is going to be this logging of analytics. So we can see here that every single one of our different URLs that have been interacted with this load balancer, we can actually break each one of these down to determine a root cause. If we look at it from the perspective of what VIP was hit, what's the server connection that's actually going to on the distant end, what the client IP is, so we have an idea of what the system they're using to interact, and we can just dig down into verbatim what is actually being sent across this to understand where these numbers come from, and analyze very deep into the actual packet flows as they traverse our load balancer. Another benefit that Avi provides is going to be what I mentioned a little bit earlier, is going to be that security aspect of this. So Avi is a robust enterprise load balancer. So it comes with what you'd expect from the perspective of an enterprise load balancer. So we have SSL certificate termination, as well as SSL certificate pass through. We have the ability to determine, what level of TLS is actually used for our application. We have analytics here to understand what's being blocked, what sort of attacks are occurring. And we can also use this to enable web application firewalling, so that we can start getting really granular with the application, with the different traffic flows that are coming into our application to prevent some of those common attacks, SQL injection attacks and things like that. But that's a feature that we get that you'd expect to have, if you were deploying an enterprise load balancer, and that's something you would get now to incorporate into your Kubernetes clusters as well. So just to kind of put all that together, and to review this. So we have multiple clusters. We have an application deployed on one of our clusters. Every one of our clusters are managed by TKG. And then the Ingress, so all of our endpoints that are exposed to the public are all going to be provided by Avi. So we have this here. We see our visibility. We can see exactly how our traffic flow is going to work. We can even see the service engine that's physically instantiating this. This is that service engine we looked at the virtual machine at earlier. So we can see that that's where the traffic's actually flowing through. And so if I come over here and test this out, we can see how using the same URL with different URIs, we can actually filter the services that we're actually engaging. So if I go to the root of this app.nsx-ALB sterling.lab, we can see I'm getting my Nginx service. So if we take a look at back here, we can see that this is exactly what's expected. So anything that hits the root is going to be sent to this service that is for my Nginx. And we can see the traffic flows that are specific to that. But if I change this to my other application, go figure, I can see that I get sent to a different application. And if you think about this in the construct of a large microservices-based distributed application, this would be different services in your architecture. So say you have a service that is for authentication, a service that is for your store, a service that is for your chats or things like that. You can enable that all through a single management point in a single URL or a single API if that's how your application is built. And again, another one, I don't have any pages running on this, but this is running Apache 9. So I can see that this still is filtering me to a different application solely based on what URI I'm actually using to interact with my cluster. And as we pointed out earlier, this is all being ran in TKG on our multiple different clusters from an application perspective. So with that, I will jump back over here, and I kind of want to just summarize what we've talked about, and then we can do any questions, and then we'll call it a day. So from a solution overview perspective, so using NSX Advanced Load Balancer is specifically the Essentials Edition, when we're talking about Tanzu Basic from a licensing perspective, is definitely one of your fastest paths to adopting Kubernetes in your vSphere environment. It can be deployed in a brownfield environment, and it can be something that can be done very quickly without disrupting your day-to-day operations as they are. So what I mean by that is, just like you saw that I had those virtual Kubernetes clusters deployed on my environment, I also had several other virtual machines still running without any issue with interacting or service contention with those Kubernetes clusters. So what that provides you is a full gamut of tools to deploy your clusters, manage your distributed architectures, and then using Avi, provide ingress into those clusters so that your application is now built with the infrastructure that supports it. You can do that all alongside what you're doing in your traditional environment today. So if you're a vSphere customer, you have a vSphere environment today, you don't have to change or destroy and rebuild anything to go ahead and enable Kubernetes and enable that process to start migrating applications, if it makes sense, into a distributed architecture such as Kubernetes. NSX Advanced Load Balancer, as we go kind of further down that licensing stack, if we have the higher licenses of NSX-ALB specifically, we start providing a lot more of those robust features that you would expect out of a enterprise application delivery controller. So that would be things like, specifically, this is usually a large decision point for customers or consumers of this, is going to be GSLB. GSLB is global service load balancing. And what that allows you to do is actually have your load balancer act as an authoritative DNS server to load balance across multiple sites. So what does that mean to you, or how does that actually benefit you? Is using this type of a service gives you the ability to have multiple data centers, and those data centers can be on-prem, they can be colos, or they can be in the cloud. And you can have a single entry point into your application, even if it's distributed across multiple disparate locations. So if you have a stateless application that is running a web front end, for example, and you want to be able to service customers as needed, but you want them to be, you want to serve them the content that is going to be closest to their geographic location. So GSLB will be able to register all of your different sites. Say a customer from the West Coast makes a query into your Ingress VIP, because Avi is being that authoritative DNS service, it's going to provide the IP address of the service for the data center that is closest to their location. So if a user from the East Coast does the same thing and actually makes a request, it'll send that to the data center that is closest to them on the East Coast. So what it's really doing is bridging together all of your different sites and allowing you to have a very deterministic failover or active data center type environment. So NSX Advanced Load Balancer, in summary, is a way that you can incorporate Ingress into your Kubernetes clusters using TKG to manage them, as well as provide yourself with a software-defined load balancing fabric for all of your applications within your data center. So with that, I'll just see if there's any questions, and then we will close it out.
Yeah, Billy, we do have a couple questions here. One is, do you need TKG even if I am not integrated with any cloud? Can I use NSX Advanced Load Balancer if I am only running vSphere on-prem at this time?
Yes, absolutely. And in fact, if we're talking about that first licensing that I talked about in Tanzu Basic, that is going to be only on-prem environment. So if you purchase a license for Tanzu Basic, that includes Avi Essentials. So when you go through and you deploy your TKG clusters in that environment, they will include a deployment of an Avi controller and subsequently Avi service engines. So they can be a completely on-prem solution that doesn't require any sort of cloud presence at all. Hopefully that answered that.
And then it says, what about full dev lifecycle in enterprise?
Yes, absolutely. So full dev lifecycle, I would assume you're referring to like a CI/CD pipeline for when you're developing application, making changes to that. Yep, for on-prem. So there are different solutions you can use. So again, this is deploying Tanzu Kubernetes Grid is still a CNCF conformant distribution of Kubernetes. So any tool that you're using today for your CI/CD pipeline can be integrated into this. So if you're using a GitOps type model with Argo or Flux, or you're using GitLab as a CI/CD pipeline tool, you can still integrate that directly into TKG clusters. And Kubernetes is that abstraction platform that allows you to do that. So because Kubernetes is the platform that abstracts the infrastructure away, as you're writing and developing your applications, the CI/CD pipeline that you're using today can be integrated and deployed to Kubernetes. vSphere is just going to provide the lifecycle for the infrastructure of those assets, and then Avi is going to be where some of those Ingress or load balancer type objects are instantiated. So I see your question. So can I get all this with Basic? So like I said, Basic is going to be, you're going to have a platform. So you have your vSphere platform, and it will be enabled with Tanzu, meaning that you will deploy a management cluster. That management cluster will then deploy subsequent guest clusters. And in this, it will deploy Avi. So you'll have your load balancing for all of your load balancing needs within the cluster, as well as your Ingress. Yeah, you can deploy your clusters however you see fit within on-prem. And if you're using an existing CI/CD pipeline today, like I mentioned, GitLab's a popular one. If you're using something like Argo or Flux, you can incorporate that into your TKG clusters just as you would in a normal Kubernetes environment. So, and everything that I've shown here, the TKG multi-cloud aspect of it, that's not going to come with Tanzu Basic. But that is really just the ability to deploy TKG clusters into AWS or Azure. So for the highest level of licensing for Tanzu, and your question is, so I would not need advanced to get a rich feature set. That's correct. I mean, it all depends on what perspective you're coming from. So if you're coming from an operations perspective and your goal is to provide a Kubernetes platform for your developers or for your application owners to deploy like container-based applications, you can absolutely do that, and it supports any sort of feature on-prem if that's your goal. Yeah, for DevSecOps, that's included. So whatever pipelines you're using in the open source environment, you can incorporate into the TKG ecosystem just as you would any other Kubernetes environment. So like I said, with Tanzu Basic, you do get the ability to deploy clusters on-prem that are lifecycle managed by vSphere. And then you also get you're entitled to Avi Essentials, which will provide the load balancing and Ingress for those clusters.
Awesome. And we have one more question. Can Avi be used only in VMware environments?
No, yeah, absolutely. So it can be used wherever your applications are sitting. So I think Avi is more akin to a traditional, or not traditional, but when you think about Avi from a feature set, it'll be very similar to a normal enterprise application delivery controller. You can deploy Avi in the cloud to distribute load across those resources, or on-prem in vSphere, wherever your applications are, Avi can be deployed in some fashion, and that even includes OpenStack, things like that. But yeah, so Avi is not tied directly to TKG in any way. There are two tools in the tool belt used to deploy your application. So if you've got a distributed application and Kubernetes is the way that you want to go, if you're doing it on-prem, Tanzu Basic is going to be the fastest way to do that, which includes, again, Avi includes the ability to deploy TKG clusters. You can get started that way. Or if you want to deploy that and extend it out to the cloud or a multi-cloud environment, or for a migration, you can use Tanzu for that as well. And again, Avi can load balance across multiple clouds using GSLB, or deploying Avi in the cloud itself.
Great. Thanks so much, Billy. And those are all the questions we have today. So thank you everyone so much for spending your time with us today. If you have any follow-up questions, please feel free to contact any of these email aliases up on the screen. And we do record these sessions. So if you would like a copy of the recording, please don't hesitate to reach out and we will make sure to get that to you. Our next Power Block session will be next Wednesday, same time at 11 a.m. Have a great day.